All right, electrophilic addition. To dienes. In our current textbook, McMurray, this is section 14.2. You probably all remember from last semester the electrophilic addition to alkenes. You remember the name of the rule for the prediction of the product here. There are two ends of the alkene, and so the hydrogen could add to either end and the chlorine to either end, but we get one product from this. That product has the chlorine attached to the most substituted carbon, and I'm going to add for emphasis the proton there to emphasize that it adds to the primary carbon, not the tertiary carbon. And of course you all remember that this goes through an intermediate, the tertiary carbocation. And then chloride adds to this carbocation to give the product. Of course, the first step in this is the protonation of the double bond. Again, the pi bond is the nucleophile, the hydrochloric acid is the electrophile. We break the hydrogen and chlorine bond and produce the carbocation. The carbocation is the new electrophile. The chloride anion then attacks, as the nucleophile attacks the electrophile to produce the product. And I want to recall for you two critical concepts: the nucleophile and the electrophile. Now, maybe you remember the U.S. city, Philadelphia. Philadelphia, phileo, is the city of brotherly love. Phile means in, I believe it's Greek, lover of the nucleus. So nucleophile has lots of electrons. So in our case, chloride was our nucleophile. It has lots of electrons. And the carbocation was our intermediate electrophile. It's electron deficient, so it wants electrons. So these are critical concepts. And if you can identify in polar reactions for each step, the nucleophile and the electrophile, you'll be able to solve almost all of these organic chemical puzzles that come along. Now, that's all review just to remind you of how electrophilic addition occurs. The question for us today, from chapter 14.2, is what happens when we make the system slightly more complex. Now we're dealing with a diene. And how does the diene react differently than a simple alkene? So if I add HBr to this, it turns out that I get two different products. Again, now what was the name of that rule? It was Markovnikov's rule. From last semester, we had learned about Markovnikov's rule. Go back and review that if you don't recall. We get the halide added to the more substituted carbon. But there's actually another product here that we observe. And again, I'm adding the one hydrogen for emphasis. The other product we get is the bromine on the opposite end. Now in this, remember our diene, we have 1, 2, 3, 4. So there's a 1-2 position, and when the hydrogen and bromine add next to each other, this is called the 1-2 product. And when they add on the other positions at the 1 and the 4, we call this the 1-4 product, or 1-4 addition product. Now, how does this occur? So let me generalize this first. So the way that I teach this is I will always teach you a general reaction. Okay? So if we have a diene, and it can have all sorts of substitution patterns around it, and we add HX, so hydrogen bromide and hydrogen chloride are the primary ones that we do this with, there will always be, and again, I'm adding the one hydrogen merely for emphasis. Of course, the other two hydrogens, let me give them a slightly different color to distinguish them. Those two are still there. We get the 1,2 product and the 1,4 product. Okay. And of course here, X can equal Br and Cl. Those are the primary ones that we produce.